Good evening, welcome. It's the first Wednesday of the month, which means it's time for AHDB's monthly webinar. And tonight the focus is crop nutrition. We have with us tonight two members of the crop physiology team at ADAS. They've been closely involved in the latest research that we're going to be talking about tonight. I'll introduce them shortly, but before we do that, just a few bits of housekeeping. And as usual, apologies if you've heard all this before. You are all muted, that's just a reminder. This is being recorded so you can catch it afterwards, or other people that you come across who've missed it can also watch it. If you've already applied for basis and Noroso points for this, you don't need to worry, but if you haven't, I'll show you in a minute how you can send in your details. We need those before we can apply on your behalf. At the right hand side, you'll see some little pointers. You click on that red arrow, that will open up that screen, and then you need to find the question box a bit further down. Click on that, open it up, and you can type in your details. You can also use that to ask questions, which we'll be inviting later on. That's probably inaccurate, but we're due to finish somewhere in the region of 8 o'clock until past. I'll give you a bit more detail on that in a minute. We can move on to the agenda slide, please. Now then, after I've finished, we'll start off with our first speaker who'll be dealing with nitrogen sulphur management for spring barley. Then all of the other stuff, all the other crops, oats, oilseed, rape and wheat will be dealt with by Sarah Clarke, which makes it sound as if Sarah Clarke's a lot busier tonight than Sarah Kendall. But if you look at the timings, which are approximate, that's not quite the case. We think Sarah thinks we'll probably go a little bit longer than the 20 minutes allocated there, but we are anticipating finishing the whole thing by 8:30 at the latest, and we aren't sure at this stage how much of that will be continuing the webinar and how much will be questions. We'll leave time for some questions, so get yourselves thinking about that. I just want to mention this arable review, which is available. You can find it on our website. If you can't find it on the website, just put into Google, just put AHDB arable review, and it will take you to it. In there, you can find an overview of all the current AHDB research in arable. And if you want to order it, you can order a hard copy in the normal way. You can also just download it and read it online or whatever. Then the next edition, there'll be a new one that will be coming out in October, and it will be sent out with the October edition of Arable Focus. So moving on to our speakers, they are showcasing for us really the latest crop nutrition research. It really is hot off the press, so much so that they were still preparing the data certainly at the end of last week, probably the beginning of this week as well. We've got both of them, as I said earlier, both from the crop physiology team, Dr. Sarah Clarke and Dr. Sarah Kendall, both of whom we've worked with closely in the past. Everyone attending, if you have any questions, send them over. We've got two experts here, make the most of them. We've also got a few questions for you just to start things off in the form of a couple of polls, but we'll do that before we hand over to the first Sarah. I don't think that's going to cause confusion because we've got a Sarah K and a Sarah C, but because they've got the split between crops, I think it'll be fairly straightforward. Anyway, our first question for you: how have your winter crops been affected by the dry conditions? For visual drought symptoms, very affected. Suspect model effect, I don't understand that, but we've changed it incorrectly. In desperate need of rain, starting to be affected. Recent rainfall will have helped. Not affected or don't know. If you can choose one of those, please. I don't think many of you will be in desperate need of rain anymore after what we've had. That's the number 2, which isn't very well written at the moment. Sorry about that. Anyway, here are the results. Starting to be affected. Recent rainfall will have helped. Yeah, okay. Thank you for that. Shall we move on to the next question? Have you altered your nitrogen management in response to the recent dry conditions? Number 1, yes, altered timing, yes, altered rate, yes, altered timing and rate, or no. That's a fairly quick one, I think, as well.
Just give it another few seconds, got a few more coming in.
Thank you, Christian. That's more varied. Well, I'm not going to comment on them any more than that, and I'm going to hand over at this point to our first speaker. Thank you, Sarah Kendall.
Thanks, Judith. And thanks a lot for inviting me to speak this evening about the work that we've been doing at AHDAS over the last 3 years, looking at the management of nitrogen and sulphur fertiliser for spring barley. Before we move on, I'm afraid I'm going to bug you with a couple more polls. And this is really just to set the scene a bit and for my own information from a spring barley perspective. So the first question is just to ask, for those of you listening, what market are you growing or advising on the spring barley for? So is it for feed, grain distilling, brewing, malt distilling, or is it a mix?
About half voted. I'll just give it a couple more seconds again.
So we've got a mixed bag here. Actually, the majority are growing spring barley for feed. And then I can see that we've got a quarter growing for malt distilling, a small percentage growing for brewing, and then just under 30% as a mix. And that's useful actually as we go through my presentation, thinking about the different markets. Okay, if we can move on to the next question, Christian. So this is just a question really about when you're applying nitrogen to spring barley. And so if you can choose one of the answers, so the first is that you're placing some fertiliser at drilling. The second is that all is applied to the seed bed within a range of 0 to 5 days after drilling. The third is that you apply up to 50% at drilling and the remainder by stem extension. The fourth choice is that you don't apply any in the seed bed or you're not placing fertiliser. And the fifth is that you have another strategy. Okay, so we can see here that the majority, so over half, are applying up to 50% at drilling and the remainder by growth stage 30. And actually that's in line with the BSFP data that we've been looking at, which shows that most people are using at least 2 splits for their nitrogen to spring barley. 16% are placing fertiliser, and then we've got a small amount, only 5%, where no seedbed N is being applied. So thanks for that, it's useful information as we go forward. So if we can move on to the next slide, please, Christian. So really, I'm going to spend the next half an hour or so talking through the main results from an AHDB and industry funded project that is really finishing at the moment. So we're just in the final stages really of writing the report for this, which should really be available within the next couple of months. So it's important to highlight that we've been collaborating with Steve Hode and Ian Bingham at SRUC on this project. And I also just want to acknowledge the partners in the project. So we've worked with the breeders, Limagrain and Syngenta, fertiliser manufacturer CF Fertilisers, Adams and Howling, who are grain merchants. MAGB have been very important in this project because through them, the maltsters have undertaken micro-malting assessments of samples from the trials with the aim that we ensure that the data and the recommendations that come out of this project take on board any implications for quality, which is obviously important from a malting perspective. We've also had a collaboration with Seges in Denmark and Chuggus in Ireland, and they've both provided considerable amounts of data that has fed into the project and helped us to make comparisons with other countries where there's considerable similarities in growing conditions, etc. If we can move on to the next slide. So as a bit of an introduction really to the project, a review of RB209, which took place in 2016, highlighted that there was a real need for new evidence to support nitrogen recommendations for spring barley. And this was really predominantly that there was no new evidence available for timing recommendations, and also that there is uncertainty around targeting different grain N percentages from a quality perspective. We know that in recent years the area of spring barley has grown due to greater demand for spring cropping, mainly due to the challenge posed by blackgrass and growers looking for alternatives where they may have stopped growing oilseed rape. And so what this means is that the area of spring barley the crop is now extensively grown on heavier ground, and this has implications in itself. We know that balancing nitrogen rate to maximise yield and targeting particular grain N percentages to meet market requirements can be challenging. And it's a challenge in trying to balance these two aspects. And I think this is particularly difficult whereby growers may be new to growing spring barley and they don't necessarily have the previous experience in growing the crop from a quality perspective. The other aspect that we wanted to address in the project is to look at modern high-yielding varieties and whether or not they actually have higher nitrogen requirements. So we know that spring barley yields have been increasing by average of 0.4 tonnes per hectare per decade. And this is really likely to be a result of improvements in terms of varieties and also crop management. So what we're trying to address here is, do these modern varieties actually need more nitrogen to achieve their yield potential? And additionally, the project has also had a smaller focus on sulphur and looking for new evidence to back up really the recommendations for sulphur for spring barley. Okay, if we can move on. So before I get stuck into the results, I just wanted to really go over and reiterate what the current recommendations in RB209 for spring barley currently are. So the nitrogen rate recommendations start with a baseline for a feed crop, and this should then be amended according to the expected yield, so whether that is greater or not than 5.5 tonnes per hectare. And the recommendation is that an additional 20 kilos of N per tonne would be applied up to a maximum yield of 9 tonnes. So that takes into account yield. The next question is, what about grain N, and what's the target grain N for the crop? And you can see in this table that essentially there's a group of rows that are for the feed market, and then there's another table below that is from malting barley, so a 1.8 grain nitrogen. And you can see here in general that those nitrogen rates have all been reduced by 30 kilos of N per hectare. So then the recommendation is that based on reducing grain N by 0.1%, reductions in nitrogen rate are made for 30 kilos of N per 0.1 grain nitrogen percentage. So the recommendation really takes account of what's the target or expected yield and what's the market requirement. So what's the target grain N? If we can move on to the next slide. And in terms of nitrogen timing guidance, actually it's a little bit complex because it takes account of drilling date, soil type, and also end market. So here you can see that if the crop has been drilled before March, 40 kilos of N is recommended to be applied in the seed bed or the 3-leaf stage for light soils, and the remainder should be applied at early stem extension, but not before early April. And if a total is less than 70 kilos, this should all be applied at early stem extension. If we look at March and later drillings, the recommendation then moves towards all the nitrogen can be applied in the seed bed, but if more than 70 kilos is to be applied on a light soil, then this should be split between 40 kilos in the seed bed and the rest at the 3-leaf stage. And finally, in a malting context, there's recommendations around the latest dates that nitrogen should be applied. Although it's interesting because these are linked to by the end of March or mid-March. So you could have questions around if you're drilling the crop in April, what would happen in that situation? And it was interesting to see the results from the poll actually and how that links in with the recommendations. And you know, perhaps there's some quite significant differences in terms of practice. And for those crops that are drilled in March, I suspect that many growers are still splitting the application and not applying it all in the seed bed. If we can move on, please. So I just wanted to summarise the experimental design before I go through the results. So just to really highlight that we carried out experiments across the UK. So AHDAS had sites in Norfolk, Nottinghamshire and North Yorkshire, and SRUC had a site at East Lothian in Scotland. So in the Norfolk, Nottinghamshire and East Lothian experiments, we had nitrogen rate, sulphur rate and nitrogen timing experiments that looked at multiple varieties. So for the nitrogen rate experiments, we looked at Planet, Laureate and Concerto. So we used Concerto really as almost a control variety. And so we were interested in the difference with the higher performing modern varieties, Planet and Laureate. For the sulphur rate, we looked at 5 sulphur rates, and this was just for the Laureate variety. And then for the nitrogen timing experiment, we included Diablo as well. So we had 4 timing treatments and 4 varieties. And at the North Yorkshire site, the experimental design was very similar, but the variety was KWS Arena in 2018 and then Laureate in the next 2 years. We can move on to the next slide. So this slide really just gives a bit of background to the sites. So we obviously have covered a range of regions. We've looked at different soil types. So generally we had light sand soils in Norfolk, medium soils in East Lothian. The soils in North Yorkshire tended to be shallow, and then we had medium to deep clay soils in Nottinghamshire. So we were trying to really represent a range of different soil types and growing conditions. You'll also notice in the drilling date column that there was a range in drilling dates. So the experiments drilled in 2018 were all drilled relatively late, so into April. And actually in 2019, at the English sites, those were drilled in the later part of February. And then the experiments in 2020 were all drilled in March. So we hope really that by having a range of different drilling dates and soil types and regions, that our data is representative. Okay, if we can move on. So I'm just going to start now by summarising the results from the nitrogen rate experiments. So if we move on to the next slide, please. So I'm not expecting anyone watching to look at all these graphs and read them very carefully, but this is just to show that we've done 11 nitrogen response experiments in the project. And in each of these graphs, you can see coloured squares, which represent the data points for each variety. And then there's a curve which represents a modelled curve fitted to those yield values. And in each graph, you should be able to notice a red triangle, and that represents the economic optimum nitrogen rate. And so that's what we're really interested in these experiments, in being able to calculate and understand. So one thing to point out here is that what you can see is that across the 3 varieties in the experiments where we included Planet, Laureate and Concerto, we weren't ever able to statistically show that the economic optimum N rate differed between the varieties. So Laureate and Planet didn't have higher optimum N rates than Concerto. If you can move to the next slide, please. So these graphs are very similar, but they represent the grain nitrogen content. And you can see again, we've used the red triangles to indicate where the economic optimum N rate is. And obviously from a spring barley perspective, we're particularly interested in not only understanding the optimum N rate and the yield at the optimum N rate, but also the implications that this has on grain and percentage as well. Move to the next slide. So I really want to highlight that we see a large variation in the economic optimum across the sites. So in this table here, we've got the different sites, the optimum N rate, the yield at the optimum N rate, and the grain N percentage. And so across these 11 sites, we showed an average optimum N rate of 118 kilos of N per hectare, an average yield at the optimum of 7.4 tonnes per hectare, and an average grain N percentage of 1.63%. But you can see that there's considerable range that's driven really by the environment, with optimum N rates ranging from just 30 kilos at the Norfolk site in 2020 through to 219 kilos at the North Yorkshire site in 2018. If we can move to the next slide, please. So I mentioned when we were looking at the N response curves that we weren't able to statistically show that the optimum N rate did differ between the varieties. So what we were seeing was that in general, all varieties responded similarly to nitrogen rate, and they had the same nitrogen optimum. But actually, when we look at the data across sites, what we can show is that Concerto does yield less, and it yields 0.65 tonnes per hectare less than Planet and Laureate at the optimum N rate on average. But we don't see any effect on grain N percentage. So we see a significant reduction in yield, but this doesn't transpire, for example, to a higher grain N percentage on average. And so I'm a physiologist, and I'm interested in trying to understand from a physiological perspective where these yield differences come from. So in the graphs below on the screen, we looked at the different yield components to try and understand things and try and explain why we found Concerto to yield less. And so what we saw was that in Concerto, there was a significant reduction in the number of ears per metre square. And we also saw a significant reduction in the 1,000 grain weight as well. So it looks like this yield reduction in Concerto comes about through a lower number of ears per metre square and lighter grains. Interestingly, we also were able to show that Laureate on average had a lower number of grains per ear. But when you look at the bottom left at the chart showing the grains per metre square, actually you can see no significant effect across the 3 varieties. If we move on to the next slide. So thinking back to the recommendations in RB209, I outlined that we start by understanding the SNS index, and then we move to thinking about what the expected yield is. And so what we wanted to do with the data that we had obtained from the nitrogen response experiment was to try and confirm the relationship between yield and the demand, crop end demand. And what we did here was we coupled the new data that I've just talked through with a refined UK review data set with experiments that were performed between 2005 and 2017. And we excluded from that data set older varieties that we felt were less relevant. And you can see in this figure here where we've plotted yield against total nitrogen content, which is really representing the nitrogen, the crop end demand, that there's a good relationship between the two. And what we can show is that for each additional tonne of yield, there's an additional 22 kilos of N per hectare requirement in terms of crop end demand. And we're able to show that this equates to a fertiliser requirement of 33 kilos of N per hectare. So this is obviously a greater increase per tonne of yield than is currently recommended in RB209. If we can move to the next slide, please. So when we're thinking about nitrogen rates, the next step is trying to think about the grain end percentage target and getting that right. And in RB209 at the moment, the recommendation starts with a feed crop, and the data that's behind the recommendations shows that those crops have an average grain end percentage of 1.9%. And so what we were interested to look at is across multiple yields at the nitrogen optimum, is there any relationship with grain end percentage at the optimum? And so what you can see here is that there is no obvious relationship using the two data sources. So we see that grain end percentage is similar across a wide range of yields, and we see an average of 1.72% in the data set. However, you can see that even at a given yield or a narrow range of yield, that actually there can be significant variation in grain N between site years. And so what we think this means is that it is sensible to use a single value of grain nitrogen at the nitrogen optimum to act really as a baseline from which we then start to make adjustments in line with a particular target grain end percentage. I think it's important to highlight here, though, that obviously there is significant variation in grain nitrogen. And as I alluded to earlier, one of the real challenges with this is potentially for new growers that haven't got the experience of growing the crop, it can be quite a challenge to achieve the correct grain end percentage. If we move to the next slide, please. So we then wanted to try and confirm that actually this reducing nitrogen rate by 30 kilos to reduce grain N by 0.1% is robust. And so here, this data is taken from the new experimental data. And what we've done is taken the average nitrogen rates across multiple grain N percentages. And what we found is that in reducing the grain N by 0.1, we see that the nitrogen rate reduces by 31 kilos of N per hectare. So it seems sensible to use the approach of reducing nitrogen rate by 30 kilos in order to reduce grain N by 0.1%. But again, we do see considerable variation in this amount. And so using that previous experience in terms of the impact of nitrogen rate on grain N percentage in previous crops should really be valued, I think. If we move to the next slide. So we've looked at the impact of yield on the crop and demand. We've looked at the impact of reducing nitrogen rate to reduce grain N percentage. And so then what we wanted to try and do is bring things together to really try and understand this in more detail. This is maybe a bit of a complex graph, so I'm going to try and explain it carefully. So we've got the different coloured lines, and they each represent a grain N% target, but actually what it means is we've got a grain N percentage of 1.9 or below, and it's 1.8 or below. On the x-axis, we've got the reduction in N rate from the optimum N rate. And then on the y-axis, we've got the percent of sites that would have fallen into those different grain N% categories. So what we can show here is that if we're fertilising at the optimum N rate, so we're looking at 0 on the x-axis, that we've got 80% of the crops would have a grain N percentage of 1.9 or less, and this falls to 63% of crops if we look at the 1.8% grain N or less. So if someone wanted to achieve a grain N of 1.8 or less, they would look to reduce the nitrogen rate from the optimum by 30 kilos, and then the proportion of sites that meet that target grain N percentage increase to 80%, and you can see if the nitrogen rate is then reduced further to 60 kilos, that 100% of the sites would then fall under the 1.8% grain N target. So we're using this to try and consider the proportion of sites that would actually meet these different requirements using the data set that we've got. If we can move to the next slide, please. So of course, I mean, it's all well and good to reduce nitrogen rate to meet a target grain N percentage, but of course, comes with that is a reduction in yield. So in this graph, we're really showing how reducing nitrogen rate on average, the impact that that has on the yield reduction. And so what we can show here is that if we reduce the nitrogen rate by 30 kilos, on average, we will reduce yield by 0.23 tonnes per hectare. And when that reduction increases to 60 kilos, the yield reduction obviously increases further. If we move to the next slide, please. And then in this slide, we've tried to really bring all this together to look at things from an economic perspective. So in this example, we're considering that the target is to achieve a grain N percentage of less than 1.8%, so say for brewing. So we look at the optimum N rate and consider how much nitrogen should be reduced in order to meet that. So in this graph, we're looking at the reduction in N from the optimum N rate against the gross margin in pounds per hectare. And we've looked at this across 3 different premiums, so £20 a tonne, 30 and £40 a tonne. And so what this shows really is economically the benefit of reducing the nitrogen rate by 30 kilos in order to improve the chance of meeting the grain N percent target. But what you can see is if you went to an extreme of reducing the reducing the nitrogen rate by 60 kilos, that although you've increased the chance of obtaining the right grain N percentage, actually the yield reduction and the cost of that yield reduction outweighs the premium that would be obtained. So it's a balancing act. Okay, if we move on, please. So I'm now going to talk through the results from the nitrogen timing experiments that we've done. So in the next slide, this highlights the treatment. So if we can move on, please. So we've got 4 nitrogen timing treatments, and you can see here how the nitrogen was split between the different growth stages. So we've called these seedbed, RB209, late and little and often. And so the important thing to draw attention to here is that the late treatment is a treatment whereby there was no nitrogen applied in the seed bed and all the nitrogen was applied in one application between growth stage 14 and 30. In the RB209 treatment, we've got 40 kilos applied in the seed bed and the rest applied between growth stage 14 and 30. And then in this little and often application, we actually saved approximately 1/3 of the nitrogen, and that was applied late between growth stage 37 and 39. And it's important to just highlight that the nitrogen was incorporated at drilling in the Nottinghamshire and North Yorkshire sites, and it was broadcast at drilling in Norfolk and East Lothian sites. Okay, if we can move on. So the important message from the experiments that we've done is that applying no nitrogen in the seedbed significantly reduces yield. So you can see in this graph here that the late timing treatment, that yield is significantly less than all of the other 3 timing treatments. We also saw no significant effect of nitrogen timing on grain end percentage or specific weight across the sites. It's important just to highlight though that on an individual experimental basis, in 4 of the experiments, we did see a significant effect on grain end. And in 3 of the experiments, the late treatment significantly increased grain end percentage. And in 1 experiment, the little and often treatment with the later N application resulted in a higher grain end percentage. If we can move to the next slide, please. So if you care to think back to the last couple of years, the conditions that we've experienced recently have also been seen recently in terms of other spring conditions in 2018, 19 and 20. And so actually our project has really kind of incorporated the effect of dry springs. And so there was potential that this may have had an implication in terms of the results here when we're thinking about nitrogen timing. So in 3 of the experiments, we had less than 1 millimetre of rainfall within 14 days of the nitrogen applications. And so we were interested to look at the total amount of nitrogen that was taken up by the crop to try and understand whether the yield effects that we observed were potentially due to limitations in terms of nitrogen uptake following some of the applications. But what you can see in this table here is across the sites that there was no significant effect of nitrogen timing on total nitrogen uptake. We move to the next slide, please. So again, we're interested in trying to explain the yield reduction that we observed. And so we looked at the components of yield. And what we were able to show is that nitrogen timing affects yield predominantly through less grains per ear. So we saw a significant reduction in the late treatment where no seedbed N was applied in comparison to the other timing treatments. We also saw a significant reduction in the number of grains per metre square with the late treatment, but this was only in comparison to the little and often treatment, so it wasn't across the board. We can move to the next slide, please. So we've just shown that it seems that the no seedbed N treatment results in less grains per ear. And so actually we did some additional assessments at some of the sites on the laureate variety to try and look at how nitrogen timing affected the pattern of tillering through the season. And so this table just represents an example really. And what we could see is that the no seedbed N treatment resulted in secondary tillering in some experiments. So if you look at the row, the percent of shoots lost, what you can actually see is for the late timing treatments that this was negative. So we saw a higher number of ears per metre squared than we'd measured as shoots per metre square at growth stage 33. So what this really indicated was that there was significant secondary tillering And we were able to confirm this as well through a significantly higher proportion of screenings with the late treatment. If we can move on, please. So this is just a very brief summary, an overview of what we've looked at in terms of sulphur, and it really doesn't do the number and the amount of experiments justice. But what we saw across the 11 trials where we've looked at sulphur is that in just one of the trials we saw a significant yield response to sulphur, and that was in response to 40 kilos of SO3. And in 2 of the 11 trials, we showed that there was a significant increase in grain N percentage with increasing sulphur rate. And actually it's interesting because we made a range of measurements in these experiments. So we measured sulphur in the soil, we looked at the malate sulphate ratio in the tissue at growth stage 32, and we also measured sulphur in the grain. And in many instances, actually, we were able to show that there were signs of deficiency, but you can see that in terms of the yield results, we weren't seeing significant responses to sulphur in some of these situations. So our recommendation on the basis of our results is that really we haven't got strong evidence that there should be changes to the RB209 guidance, which is currently to assess the risk of sulphur deficiency, and also if deficiency is suspected, to use tissue and grain analysis, and then to apply 25 to 50 kilos of SO3 between mid-March and mid-April if there is a risk of deficiency. So if we can move to the next slide, please. So I'm just going to wrap up now by giving some conclusions. That was a real whistle-stop tour through the results, really. What we found is that increasing yield results in an increase in nitrogen demand, so an increase in the fertilizer requirement per additional tonne. Our experiments confirm that a reduction of 30 kilos of N per hectare is sensible in order to reduce grain N percentage by 0.1%. The average grain N percent at the optimum is just 1.7% across our experiments and the review data. So that's actually considerably lower than the 1.9% that the RB209 recommendations are based on. The experiments highlight the importance of some seedbed N in a dry spring. So in 4 of the 11 experiments, we saw significant yield reductions where no nitrogen was applied, and this was true when we looked across the data set. But the important thing here is that actually there's large flexibility in terms of nitrogen timing, which means that as long as some nitrogen is applied in the seedbed, those further nitrogen applications can be really targeted to when the conditions are best. Delaying the application of 20% of nitrogen until growth stage 37 may increase grain N percentage with no effect on yield, which could be beneficial if high grain N percentages are being sought after. We saw a significant increase in yield from sulphur at just 1 of 11 sites. And the other thing, which I haven't gone into any detail about, is that really when we think about our conclusions and what these may mean in terms of RB209 recommendations, we're able to confirm that any changes won't have a negative effect in terms of malt quality or whisky flavour through the data that we've obtained in the micro-malting assessments as well. And on that note, I'll finish and hand back to Judith.
Well, thank you very much, Sarah. You said it was a whistle-stop tour. Thank you for keeping so well to time. It was full of interesting stuff, loads of it, absolutely packed with information. We do have some questions coming in, and I'm going to pick a really, really short one because I think this won't take you long to answer, and then we'll hand over to Sarah when she's ready. But somebody's asked, did you do any work on seed rate?
No, so in our experiments, all the experiments have been drilled at 350 seeds per metre square. So we haven't been able to take account of optimising seed rates in these experiments. I think probably there's been quite a bit of work done on kind of optimum seed rates for spring barley. The only thing I would add though, I suppose, is as some people are starting to move towards no-till situations and things, it may present a situation where there is work that we've done in the past that maybe needs to be revisited for that different kind of farming system approach.
Great, thank you, Sarah. And at this point, let's hand over to the other Sarah. Over to you. Thank you.
Thanks very much, Judith. And good evening, everybody. I'm going to be, as Judith said, talking about a range of topics this evening. And I'm going to start off by talking about some oats research, which is going on at the moment. This isn't a completed project, as Sarah's been describing on the spring barley. This is an ongoing project, but I'm just going to give you a bit of an update of what we're finding so far. But before we get going on that, I just had a couple of polls that I'd like to present. The first one, the question is, if you are growing or advising on oats, are the N rates you're applying, A, following the current RB209 guidelines, B, higher than would be recommended by RB209 currently, or C, lower than RB209, or D, do you not consult RB209 for oats rates, or do you not know? So that's the first question to kick us off on the oat side of things. We'll just wait a few seconds for the results.
Yeah, I'll give it a few more. I'll close it.
Okay, so nearly half the people are following current RB209 guidelines, and about 30% don't consult RB209. So it's interesting also to see that 20% are lower and only 8% higher than what would be recommended by RB209. That's really interesting, and as you'll see a bit later in my presentation. And there's one more question I'd like to ask. This is about spring oats. And if you're growing spring oats or advising on spring oats, what proportion of nitrogen are you applying in the seed bed or within 5 days of drilling? So is it none, less than 25%, 25 to 50%, 50 to 75%, or more than 75%? So I'll just give you a few more seconds to answer that one, and we'll see the results. Um, 25 to 50% is the most popular there, and that tallies quite well with a survey that we've done as part of this oats project as well. So that's really useful and interesting. So thank you very much for responding to those polls. So I will just have to show my screen. So I shall, yeah, so hopefully.
Yeah, we can see that.
Has worked. Great.
You're good to go.
Thanks. So as I said, I'm going to be talking about an oats project that we've been doing for AHDB, and it's an industry funded project. And it started in 2018, but it's ongoing, as I said. So just a bit of background about oats. Oat supply and demand are both increasing, and this graph just shows over the last 20 or so years how the supply in the light blue, and the demand in the red are increasing. It's a couple of years old now, but we recently heard that there's going to be an increased capacity at the Richardson's mill near Bedford over the next 18 months to 2 years. And also Oatly, who make the oat drink, are going to be producing that in the UK as well. So there's going to be increased capacity there too. So this demand is certainly increasing, and we're also seeing that growers are increasingly interested in growing oats as well, for a couple of reasons. Diversification of rotations as a replacement for oilseed rape, but also particularly for spring cropping. We've certainly seen a big increase in the proportion of spring oats that are grown for blackgrass avoidance and other methods. There are some issues with oats. There's quite a large gap between the average oats yields that you see in the DEFRA stats and other stats, and also the best farm yield. So there's this big, about 4 tonne per hectare gap between the average and the best yields. And some of the reason for that is there is a lack of knowledge about growing oats, both in terms of physiology and also agronomy. And physiology has taken a step forward understanding the physiology of oats. Working with Quaker and other partners, we've developed the Oats Growth Guide now, which gives some good benchmarks for oat growing, which has really helped to start understanding the physiology better. But there's still a big gap in the agronomy. So this project that we're doing at the moment is trying to help improve yields and quality with nutrition. And quality for oats are particularly important. Growers often struggle to meet the specifications on specific weight and screenings. Those are 2 big issues. And also other quality parameters like kernel content and hullability. I haven't really got time to talk much about the quality results of this project this evening, but that will be a big part of this project as well. So where we started with this project was based on the findings from the 2016 RB209 review. This showed that there wasn't enough data to derive good recommendations for winter oats. It was clear from the results we had that actually the current recommendations back in 2016 were too low. So there was an increase of 40 kilos of N per hectare applied to all soil types and all SNS indices for winter oats. But there were absolutely no data on winter oats N timings and nothing at all on spring oats either in terms of the nitrogen rates or timings. And even if you look now at the RB209 in the spring oats section, there's a big gap where you might expect some instructions about timing. So there's clearly a need to improve the recommendations for oats. So this is where the oats project came from, which we know as NoatS because we're looking at nitrogen and sulphur. So this is looking to provide advice on the best nitrogen rates and timings, and also thinking about sulphur applications to optimize yield. And as I said, quality is very important as well of both winter and spring oats. And we're really fortunate, as well as having AHDB funding this project, to have a really good consortium. And I'm really grateful for the consortium's contributions. We have everybody from the oats breeders right up through the fertilizer manufacturers up to the millers. So we're really pleased with that. So we have Aberystwyth University who breed oats, who are in charge of the quality aspect of the project. We also have input from Chuggas in Ireland and Segges in Denmark to help with augmenting the amount of data that we get. But we're really lucky to have this really good consortium that incorporates the whole of the oat supply chain. So when we started the project, because of the lack of information, we thought that it would be useful to have a survey about the current state of play of what growers and advisors were thinking about in terms of nutrition on winter and spring oats. And the first thing we looked at was whether the oats areas that people were growing or advising on were increasing or decreasing. And you can see from this graph here that for the winter oats on the left, about half of the advisors said their winter oats areas were either increasing or staying the same, and with more decreasing. But the spring oats, that was a crop that is really increasing and is continuing to do so. And we found in terms of the amount of nitrogen that was being advised to apply for winter oats, on average this was about 138 kilos Vn per hectare, but there was very big range, you can see there, between 75 and 170 kilos of N. And for spring oats, the average amount being advised to apply was 118 kilos Vn per hectare, and again there was a really big range. The winter oats timings were generally as per RB209, and the timings for spring oats, we generally saw that most people were applying around half in the seedbed, which tallies with the poll at the beginning of this presentation. So that's quite encouraging. So after the survey, we then established some trials. So we have a number of core trials in the NoatS project. These are augmented by some partner trials that some of the consortium partners are carrying out, which is really helpful, but we have a number of winter and spring oats core trials. So the winter oats trials, we planned 2 seasons of trials in Nottinghamshire and Herefordshire. Unfortunately, we weren't able to carry out any winter oats trials last season because of the really terrible autumn of 2019. We weren't able to establish those. So currently we've only got 1 season of data for these trials. But at each of these sites, we're looking at 3 different winter oats varieties, which are Miscani, Southwark and Penrose. And we're looking at 2 trials. So one, a nitrogen response trial with 6 nitrogen rates. And then we're also looking at a nitrogen timing trial with 6 nitrogen treatments at different timings, and also one without sulphur. Since we've only got 1 year's of data, I don't really want to present too much on that, but it's looking like the RB209 timings that people have been using are pretty reasonable. Another thing we saw was at the Nottinghamshire site, which is a really light land site, that sulphur was quite important for yield. But as you'd expect, the nitrogen rates, the optimum N rates did differ between those 2 sites. But when we have more data, there's currently site trials in the ground at the moment, which will augment that data set. So in terms of the spring oats, we've planned 3 seasons of trials for this. So we've carried out 2 seasons, and the 3rd season of these trials are in the ground at the moment. And these are being carried out in East Anglia and also in Kinross up in Scotland. Again, we've got 3 varieties for each of those sites. but they do slightly differ. So in the East Anglia, we have Canyon and Elian and Aspen, whereas up in Scotland, we have Canyon, Elian and Conway. So again, for each of these trials, we have 6 nitrogen rates in the nitrogen response trial, and we have 6 nitrogen timings treatments in the timing trial with and without sulphur as well. So just to give you a flavour of some of the results for the spring oats nitrogen response trial, this was the trial up in Scotland last season, and you can see here the nitrogen response curve similar to those that Sarah showed in her spring barley results. So along the x-axis we have the nitrogen rates and then the yields up the y-axis. So we have the three varieties here, and we've got only a curve on the Elian because you can see that the Conway and the Canyon were still increasing their yields at the highest N rate, and this meant that actually I wasn't able to fit nitrogen response curves to this, but it just shows how much higher than the current recommendations in RB209 those Canyon and Conway would be. They'd be much higher than those. Elian, we were able to fit a curve, and that came out at an optimum N rate of 111 kilograms per hectare. Incidentally, the RB209 rate, taking account of the soil nitrogen supply for this site, would have been 140 kilos. So we've got another trial up in Scotland at the moment, which has been drilled and is looking good. So we shall see what happens this season. But we've also been looking at the quality of these samples from these nitrogen response trials. And we've got a couple of graphs here, specific weight on the left and the kernel content on the right. So a kernel content in oats, because we have husked oats, the kernel content is the percentage of the whole grain that is of the whole grain of the oat that is actually the kernel. So when you take away the husk in the milling process, what you're left with is the kernel, and that's generally over 75% of the weight of the whole grain. So what we see with a specific weight, as you increase the nitrogen rates, you often find that the specific weights are reduced. The responses at this trial site are slightly different to what we often see, which is you get an increase in specific weight as you go from 0 up to the next 2 or 3 N rates, and then a reduction. But this one is just going down as you increase the N rates. There is a big interaction with variety as well, and we see that quite commonly across different trial sites, where certain varieties maintain their specific weight really well across N rates, whereas others have quite a steep reduction in their specific weights. But you can still see that on average the specific weights are still above 50, which is generally the milling specification. So although specific weights often reduce as you increase or get to high N rates, the kernel content has the opposite effect. So you're seeing increases in kernel content with the increases in nitrogen rates. But again, we'll collate all the data from all the sites, and including 2021, to produce recommendations based on looking at yield and also quality aspects as well. So those are the nitrogen response trials. When we're thinking more about nitrogen timings, we're wondering how can we use nitrogen timing to improve both yield and also quality. And if you have a look at some of the figures from the oat growth guide, which you can download from various websites, I think also including the AHDB website, looking at the northern spring oats compared to the southern spring oats, you generally get about a week extra grain filling period. And this results in a higher biomass, and you also get a higher nitrogen uptake, and which results in a 0.2 tonnes per hectare higher yield for the oats grown in north versus the south, and also a higher 1,000 grain weight. And these figures are from the oats growth guide, where you can see the specific weight at the northern sites are quite a bit higher than those in the south. And also the screenings are quite a bit lower. So do we need later nitrogen to maintain grain filling period and improve grain filling to improve quality? Back in 2019, as part of the NoatS project, CF Fertilisers worked with a farmer in Cheshire to have a look at this on his farm. So this farmer was growing spring oats. The field had quite a high nitrogen supply in the soil already, and so the nitrogen recommendation for this site would have been 75 kilos. But what they did in this field was to look at 3 different nitrogen strategies. The first one was not to apply any nitrogen. And then the second one was to look at nitrogen in the seed bed and then at the 3-leaf stage. And the third one was to have a later slant to the nitrogen applications. So none at the seed bed, some at the 3-leaf stage, and then some at the start of stem extension. Apologies for the complicated table at the bottom, but the main points to take away are the figures in bold, which are the yield, and you can see from those yields that the later timing treatment had a much higher yield than the earlier timing. So that grower there is certainly seeing the benefits of applying the nitrogen later. We could get into a debate about moisture availability in the soil, but I don't really have time to do that, unfortunately, today, but feel free to chip in with some questions a bit later on. So that's just a brief overview of this project. As I said, there will be a lot more results to come, but currently we're seeing from the database analysis that the nitrogen recommendations in RB0209 at the moment are on the whole too low. For winter oats, we only have 1 year of data available at the moment, as I said. But there is some evidence that sulphur is particularly important for lighter soils. In terms of the spring oats, there's been quite a contrast, as you can imagine, between the East Anglian results and the Scottish results, with the dry springs in East Anglia resulting in lower yields and lower optimum N rates, whereas the results from the Scottish trials are giving high yields and high optima. In terms of looking at the timing, although we found in the sites that I described earlier that the later nitrogen may help to maintain grain filling, from the quality results that we've got from the trials, it appears that having some nitrogen in the seed bed is important for yield and also particularly for quality aspects. As I said earlier, we've got one more season of trials that we're carrying out at the moment. So the results from this project should be available by summer next year. So we'll get back to you with that one. Just want to finish with a bit of an advert. In 2021, we have a new yen category within the cereal yen, which is the oats yen. So I would encourage any oat growers out there to join this oats yen, because there is such a lack of information about oat agronomy and production. I think it's really important that we get as much information as possible to try and understand better what's happening with oats in terms of yield and quality, and I think oats yen should be able to help us with that. Anyway, I shall hand back briefly to Judith before the next.
Thank you. Yeah, Sarah, thank you very much. In the interest of time,
oh, sorry, I've gone over rather.
Well, if you're happy, we'll go straight into the oilseed rape and then follow with the milling wheat bit. Shall we do that?
No
Thank
problem.
you.
Yes, apologies. I tend to wax lyrical about oats.
You're all right. Carry on. We're a little bit late, but we'll fit it in. Thank you.
Yeah, thanks. So this late foliar nitrogen on oilseed rape, it's just a very brief update. It's no new research, but I was just asked to give everybody a very brief update about the findings from the latest project that we have on late foliar nitrogen in oilseed rape. This data is from 2015 from a industry and government funded project and trials carried out by ADAS and Yara. We had 27 trials. One of those trials, you can see on the right hand side here, was negative in terms of a yield response to foliar N. But on average, the mean yield response was 0.3 tonnes per hectare when an N rate of 40 to 50 kilos was applied to the oilseed rape. In terms of exact timing of these, we did 9 timing experiments over a number of seasons. There wasn't actually a difference in response to the foliar nitrogen applications at flowering against post flowering. The effects were very similar, and there was also a similar yield increase from stem extension timing as well. You do get the increase in yield, but you also get associated with that a reduction in oil concentration. With the mean oil response for those trials, we saw of a reduction of 0.7%. In terms of the cost-benefit analysis of applying foliar N to oilseed rape, it's often quite finely balanced. So, and it depends very much on the cost of the nitrogen, which you can see across the x-axis here, and the price of the oilseed rape. With the current high prices of oilseed rape, actually, it's probably maybe worth doing more this season than previously, but it's worth considering the situations on a case-by-case basis. So this figure illustrates the product cost and the oilseed rape price combination, which you need to achieve either £40 per hectare margin over N cost, which is the red line, or £20 per hectare over N cost, which is the blue line, or to break even. But as I said, because of oilseed rape prices being over £400 a tonne at the moment, it probably makes the equation a bit more favourable for the use of foliar N at the moment. So just to conclude, there is an average of 0.3 tonne per hectare benefit to adding foliar N late in the season, but it is important to apply this when conditions aren't too hot and less than 19 degrees C. There were the same effect from either flowering or post-flowering applications, and as you could see in the graph, there was a reduction in oil concentration. Interestingly, there was a greater response to the foliar N when either the soil applied N or the nitrogen uptake was suboptimal, which may mean that this year, where in situations where nitrogen uptake has been suboptimal due to the dry weather, it may be more beneficial to be applying this late application this season. And as I said, it's worth looking at the cost-benefit analysis on a case-by-case basis. So that's just a very brief reminder of the current recommendations on foliar N in oilseed rape. And changing tack again, thinking about late nitrogen for milling wheat. It's not always easy to achieve 13% protein in your milling wheat, as you can probably gather from both the milling premiums, and also if you have a look at the AHDB cereal quality survey, it's not easy to achieve 13% protein. And from all the data that we've seen, and quite a lot of different data sets, there's a very large farm factor involved as well, where some growers seem to be very able to achieve 13% protein very easily and consistently, where others always struggle. And we don't know exactly what the reasons for that farm factor is, but it is something that we're investigating. You can use grain protein to indicate success, and this is talked about in RB209. There is a difference between the varieties, where the optimum N rate for bread making varieties is around 20 kilos of N per hectare higher than for feed varieties. So as a rule of thumb, if you're getting about 11% protein on your feed varieties, you're fertilizing it optimally for yield, whereas if you get a grain protein concentration of 12% on your bread making varieties, you're optimizing it, fertilizing it for yield. But obviously you want to improve the actual protein content above that 12% usually. And if you look at RB209 at the moment, it says that an addition of about 40 kilos of N per hectare could increase the grain protein by about 1%. And you can either add extra nitrogen fertilizer at late stem extension, sort of growth stage 39, and that will increase both yield and quality. You can see the graph on the right, which has the amount of extra late N on the x-axis and the grain protein up the y-axis. The blue line at the bottom there shows ammonium nitrate applied at growth stage 39, which is boosting protein, and it will also boost yield. Whereas the pink and light blue lines show foliar urea applied at milky ripe stage, which is going to be boosting protein. Obviously, urea applications are being scrutinised at the moment as part of the government's Clean Air Strategy consultation. They carried out a consultation over last winter, and we're still waiting to hear the government response to that, and I think it's due in the summer. We're also trying to understand more about protein and how to achieve good yield and quality through the quality yen, where we're working with the UK flour millers, formerly NABIM, to try and understand the best way to achieve both yield and also quality. And you can see videos from the winners of these awards either on the AHDB or the Yen YouTube channels to try and see what strategy different growers are using. And just to let you know quickly about a project that's ongoing at the moment, it's started again in 2018, looking at the nitrogen and sulphur management for protein in milling wheat, and this is led by NIAB and working with the partners that you can see at the bottom of the slide. And this is looking to update RB209 guidance on nitrogen and sulphur fertiliser for winter wheat, and looking at the nitrogen and sulphur rates and timings and the impact of those on quality. And they're looking at not just protein but other aspects of quality as well, in terms of dough rheology and how the bread making process is performing. So any information on that can be found on the HB website, or you can contact Nathan Morris at NIAB about that as well. And that was my very brief update of current recommendations, and apologies again for going on too long.
No need to apologise, Sarah. I think we'll get complaints because it seems we gave you far too much to do. Absolutely masses of information there. That applies to both of your presentations, and it's marvellous. I mean, Sarah, you've just finished. You were talking about waxing lyrical a few minutes ago. I'm not surprised, really. It's pretty fascinating for everybody, and to have all that information before us, and it's coming out, it's fresh research. It's great. So I have to say thank you very, very much, both of you, for doing that. We won't let you go away just yet. We have some questions, but in the interest of time, we won't run on too much, and I think perhaps we will run on slightly. But don't forget, if you are listening in, it's being recorded, so you can catch it. But I also know that both Sarahs have got young children and may not wish to carry on for too long. So we'll do a balance, I think, and just encroach on the time for a bit longer. What I'm going to do, I'll give Sarah Clarke a rest for a bit, if you like, and ask a few questions of Sarah Kendall, if I may. There's one about seedbed nitrogen, and it says, when you say seedbed nitrogen, do you mean incorporated into the soil before drilling, or a top dressing application within 5 days of drilling?
Yeah, that's a good question, and it's important to clarify as well. So essentially we had two sites where the nitrogen was incorporated with the drill and then the seed drilled afterwards, so there was a level of incorporation. So that was at the Nottinghamshire and the North Yorkshire sites. And then at the East Lothian and Norfolk sites, essentially the nitrogen was top dressed, so it was broadcast applied after the seed had been drilled. And when we've looked at our data with that in mind, we did wonder whether the fact that the nitrogen had been incorporated into the seed bed in two of the sites, that we may have seen more of an impact of not applying any nitrogen in the seed bed. And we did see that in the Nottinghamshire experiment in 2018, but it didn't seem that there was any consistent pattern between sites when we looked at the way in which the nitrogen had been applied. But I think just linked to that as well is obviously within our experiments we've incorporated, and in some cases we've broadcast, but what we haven't looked at all is placed fertilizer. And I think as an outcome of this project, really we will highlight that as an area that needs further work, is looking into the impact of placing and whether that, you know, potentially affects the proportion of nitrogen that needs to be applied in the seed bed versus later.
Thanks, Sarah. And another one, also related point, in wet West Wales, should all nitrogen be applied in the seedbed for March and later drilling?
Yeah, so I think we obviously have to be really careful from an environmental perspective here, as well as thinking about what's best for yield. And so what I would recommend is that if there is a significant leaching risk, so if it's likely that there will be a significant amount of rainfall following drilling, then we shouldn't be advising that all the nitrogen should be applied in the seed bed. So I suppose at the moment the current recommendations are, if you're drilling March onwards, that you apply all the nitrogen in the seed bed, other than if you're on a light sand soil. But there may be other instances where there still could be a leaching risk. So I think considering that carefully is important. The other thing I will just highlight is that actually our results didn't show a negative effect of applying all the nitrogen in the seed bed versus splitting it. You know, the only thing we could show is that you need to apply something. And I think this is important because from an environmental perspective, what it actually means is that there's a lot of flexibility in terms of when the remaining nitrogen will be applied. So I think there's potential that we can be better at targeting the application based on ideal conditions, and that there doesn't need to be a huge rush to get the remaining amount applied.
And I think this will be the last barley one for a few minutes. From a feed barley perspective, are you saying that a higher rate of grain nitrogen will result in a higher protein content?
Well, yeah, potentially, yes. And I think that's, I mean, we talk about a lot of the discussion around grain end percentage is obviously about ensuring it's not too high if we're thinking about a malt distilling market, for example. But in addition, there are also brewing markets out there that want high grain nitrogen. And from a feed perspective, yes, if you want high protein, then actually I think there are ways in which you can think about nitrogen timing that may improve the chances of increasing protein in the grain from that perspective as well.
Okay, thank you. Where's that one gone? Oh yeah, this one's for other Sarah. Any comments on nitrogen for spring naked oats?
Yeah, spring naked oats, generally you can treat spring naked oats or any naked oats as you would do for winter, for husked oats. So although you get a different yield, this is due to the husk threshing off at combining. So the crop itself you should treat generally as per a husked variety.
Okay, thank you. And this one, I suppose it could be for anybody, couldn't it? Is there a limit to how much nitrogen can go on in one application, or is it more a matter of reducing risk? Who wants to take that?
Well, I can start. I don't think that there's not a textbook amount that we would say, you know, this is what you shouldn't be going over. And clearly, from a spring barley perspective anyway, in the current RB209 recommendations, there is a recommendation that all the nitrogen can be applied in the seed bed, and it doesn't give a limit to what that should be. But equally, I think, you know, we know that putting lots of nitrogen on in one go, there may be risk from, you know, from the environmental perspective that we should be trying to avoid if possible. And the other thing, just to add as a kind of general comment, is one of the things that we've seen when we've analysed data from the yen, so this is mainly thinking about winter wheat, is that we see this significant association of higher yields with a higher number of nitrogen applications, and we've seen similar for oilseed rape as well. Maybe we've got a bit of the farm factor in there, but it does seem like potentially this kind of little and often approach when it comes to nitrogen may be something that can be beneficial from a yield perspective. I don't know if you've got anything to add to that, Sarah.
I just think that the general principle of matching supply with demand is a principle that you should apply as a general rule, really, rather than saying, is there a limit to how much we should be applying in one go? It's more about making sure what you're applying is matching the demand of the crop.
Yeah.
Okay, thank you. And there's one here. Which would you apply first in the spring, ammonium sulfate or nitrogen? Fight over that one. Which one would you like to do that?
Well, I think there is flexibility in that, so I don't think there is necessarily a definite rule. And you'll have seen from the current recommendation for sulphur applications to spring barley that there is a range there. So we're not saying that getting it on really early is really crucial. So sometimes there's, you know, what product works for different farms in terms of the order that it's applied. There can be flexibility, but obviously you've then got other crops, so such as oilseed rape, where actually applying the sulphur if it's needed relatively early is more important.
Thank you. I think we'll slip in a couple more questions. I'm assuming we're not going to get thrown off the webinar platform at this sort of time of day, so I think we're safe. There's one that came in a bit earlier. Any thoughts on BFS Poly N plus type foliar sprays for improving grain protein, please? Sarah. It doesn't say which Sarah. Would that be?
Yeah, that might well be me. I haven't. I have heard about that, but and I have heard that it can improve grain proteins. We haven't done any trials on that, so I couldn't sort of comment about whether it's effective or not. But I have heard that it can do that, but as I say, we haven't tried it ourselves.
Apologise if I miss any questions out. There really will be only two more now. I think I've missed some, and we'll deal with them afterwards if needs be. For foliar N on oilseed rape, how much rainfall or irrigation is needed to get the yield benefits to justify applications of 50 kilograms of nitrogen per hectare?
How much yield? How much rain after the application?
Yeah, looks like it. Yes. Justify putting on 50 kilograms.
Well, yeah, I think there is obviously a range that you could see in that graph of the yield improvements, and I think the amount of water availability will have affected what yield response you were getting. I don't know off the top of my head exactly how much would be required to justify that. Obviously, unless you have irrigation, you'd work it out on the cost benefit analysis of the price that you're likely to get for the crop and the cost of the nitrogen, rather than thinking about the rain. I'm afraid I don't know I don't know if Sarah has any extra thoughts on that.
No, well, I couldn't put a number on
No.
rain kind of uptake. I mean, I guess, you know, quite a lot of it is being applied to the plant as it's being sprayed, and the amount actually kind of hitting the soil surface will be, well, there will be a proportion, won't there? But
This really is the last question, and I think it's open and you don't need to answer it as such, but I think it's more something to think about. Is it now time to do some trials work to sort out the wide range of recommendations for micronutrients on all combinable crops? Any quick comment from maybe Sarah Kendall? That'd be yours.
well, it's a really good point, because we did a review of non-NPKs nutrients nearly 10 years ago for AHDB that really identified that there's a huge knowledge gap when it comes to micronutrients, and I wouldn't say from an independent basis that there has been much more work done since then. So I do agree that there's a real need, and one of the things that we've kind of been looking at in Yen Nutrition, which is looking at using grain analysis to try and really learn more about how we can monitor crop nutrition, is about, can we use grain analysis to understand our success in terms of nutrition? And so, you know, things that are coming out of that are a high proportion of crops. So spring barley crops are showing manganese deficiency, and for oilseed rape, we're really interested from an oilseed yam perspective in magnesium nutrition. And so there's lots of circumstances where we just don't have the real evidence to understand if there is a requirement and what should we do about it. So what products should be applied and when should they be applied and at what rate. So yeah, I agree, but the only thing I can suggest is that, you know, some of these are trials that you can do on farm on a tram line, and so if you're kind of looking at something specifically from a micronutrient perspective, trying to understand whether something worked or didn't work is important, and potentially you can use things like grain analysis or tissue analysis to try and learn more about the success as you go.
That was a good question to finish on, wasn't it? I think it was, brings everything together really nicely where we need to go next, and that's great. Well, thank you again, both Sarah and Sarah, for providing us with all that, for answering those all the questions as well. We've just about got there, I think. Many thanks. Absolutely fascinating. It really is. You've got so much information there, and it, as I said earlier, it really is great to see. So thank you, Christian in the background, for doing all the other bits, which we'll finish off in a minute. At home, thank you for sending your questions in. That's great. It's always useful to have a good selection, which we had tonight. Just a few finishing off points from me. When the webinar ends, you'll be taken to a feedback survey. Can you please provide us with some feedback on this, so it helps to inform future webinars and where to go next with them and what to do differently if needs be. And just to remind you again, that it will be recorded, it has been recorded, and it will be available, and you'll be sent an email with a link so that you can automatically find it quite easily. If you'd like any more information, those are my contact details on there. I didn't mention in any detail the publications that are available. Do go and have a look at the website, especially if you're not familiar with it, and find some more. Let me just mention, as I said at the start, these webinars are on every first Wednesday of the month. The next one's going to be on the 2nd of June, and it will be on grain storage. And I also want to mention as well, my colleague Chris in Scotland has sorted out the podcast for this month, and it will be available on Friday, and that is also crop nutrition based. I think it's titled something like "What Do Plants Need?" So look out for that. I didn't give you the website address for contact details and so on. If we haven't got your contact details, we can't send you emails. And worse than that, we might have your contact details, but we also need your permission to use your email address. So that's ever so important. So please make sure that we have all of those strands. Reminder again about the arable review. I think that's a really useful document. Have a look at it. Order one if you need one. If you're a levy payer, you've already paid for it. It is available. It's a very good summary of a lot of the stuff that's going on at the moment. And I think for now, that's it from the AHDB webinars. Thank you all again.